Alright, so bear with me. We're almost done explaining how exercise affects, different variables in physiology shit. Whether it's maximal exercise, if they're exercising, relative exercise, absolutes. So we're just going to make a video going over explain each of these because these are very important topics and every test is cumulative, so it'll be asked many times most likely. So we already went over how training, if you compare an untrained athlete to a trained athlete, how all the values are different. And we went over what happens to all these values once you start exercising. Now we're going to take all these values again and look at how they differ between a trained athlete and an untrained athlete at maximal exercise. So the easiest way to do it is just take yourself as an example and say you are untrained, or let's just say you're out of shape and you're running at maximal exercise, which is 100% of your heart rate or 100% of your VO2, whatever formula you want to go by. But the thing is, you're just running at your maximum. You're going all out, maximal strength, you're dying, whatever. Yeah, you're going all out. So how do all these values differ? You'll reach a certain value with like a certain max heart rate, a certain max stroke volume, a max cardiac output, a max VO2, etc. And now say you decide to get in shape, so you go train now. And now, since you're trained, you also run to 100% of your VO2 or 100% of your heart rate, whatever, to max level. Now, how does your heart rate change? How does your stroke volume change? How does your cardiac output change? Your VO2, your mean arterial pressure, your PNS, SNS, everything. How does all these values change? So now that's what we're going to be looking at. So we'll just say you just trained, and now you're running at 100% of your VO2, or let's use 100% of your heart rate, because it's easier to reach 100% of your heart rate than 100% of your VO2. You'll most likely pass out if you reach 100% of your VO2. Now, in 100% of your heart rate, you're at the absolute max. You're at your max. Now, since you're trained and you're in much better shape, how does your max heart rate change, your max VO2, your max stroke volume, all that good stuff? So these are the values we'll go over. Now, your max heart rate actually does not change. Does not change. And we'll just put a little triangle delta thingy. So your max heart rate doesn't change. The reason for that is because everyone has a certain max heart rate, and no amount of training changes your max heart rate. You're stuck with that heart rate. It's not like if you reach 200 beats per minute, which is like a normal max heart rate for a 20-year-old. You reach 200 beats per minute, you train your ass off for 6 months, and now your max heart rate is 205. That's not how it works. Your max heart rate is your max heart rate. It's the maximal strength of your muscle. Your max heart rate, the only thing that changes your max heart rate is age. It decreases with age. Based on the formula, I'm sure everyone knows, 220 minus your age. Now, this does not mean 220 minus your age is your exact max heart rate. This is for the general population, just like BMI is. A lot of people have different heart rates than 220 minus their age. Like, this says my max heart rate is 196. My max heart rate is probably 196 if I ever get to it, but it might be 197, 198, who knows. But again, it's affected by age. Training does not affect your max heart rate. Now, your max stroke volume. Now, if your max heart rate doesn't change, and we know a trained individual has a much higher cardiac output at exercise when they start exercising, and max heart rate isn't changing when they're at maximal, the stroke volume has to be changed, because if you're taking someone at max exercise and they're trained, the max is probably much greater than the untrained max. So if max heart rate's not changing, there's something else must be allowing them to reach a higher max, and it's stroke volume. So stroke volume is increasing for a trained individual at maximal exercise. The reason is because since heart rate's not increasing, because your max heart rate is your max heart rate, that doesn't change, your stroke volume has to take over to increase your cardiac output. And like we already said, your cardiac output increases. Easy way to remember it is instead of just memorizing what is happening, you take an untrained athlete, reach your max, then you take yourself and you reach your max. Your max is probably now much greater than it was 6 months ago before training. Now, what caused it to be greater? It wasn't your max heart rate that's making you be in much better shape, because your max heart rate doesn't change. Your max stroke volume has to change in order to make you in a better fitness level, and thus your cardiac output will change based on the formula. And I will always write the formula if you're ever in doubt. Cardiac output times stroke volume. Well, cardiac output is the same. Stroke volume is increasing, so cardiac output must increase. And you can do the same thing with VO2. Formula is cardiac output times AV difference. Who cares what AV difference is? Cardiac output is increasing, so VO2 must increase. Now the other ones are mean arterial pressure just doesn't increase. I really don't have a conceptual reason why. It just doesn't increase. So you just memorize it doesn't increase. Now rate pressure product. Now you can think about this two different ways again. Remember, it's the indirect oxygen consumption on the heart, or in a more friendly term, the stress on the heart. How hard the heart is working, how hard it's stressed. So since max heart rate is not changing, the heart's working at the same exact level. And you can also just write the formula, heart rate times systolic blood pressure divided by 100. Heart rate is staying the same, then mean arterial pressure is staying the same. Systolic blood pressure isn't really changing because, again, max heart rate is staying the same, so systolic is about the same. Now, parasympathetic and sympathetic are the same. Reason because you're at your max, so they don't really change. Your parasympathetic isn't even active when you're exercising, so that never changes, obviously. And since you're at your max training, sympathetic doesn't really change. So this is all that's happening when you start training. When you're at your max. And again, let's make a cool graph to memorize all these values, because these are very important. So this is for a trained athlete at their max. So you have your untrained self, you run to your absolute exhaustion, you reach a certain level, then you train for 6 months, and then you run to absolute exhaustion again. Well, now your max is probably much greater after training, because that's the point of training, so you're in much better shape. Now, when you enter max, how do all your values change? How do your heart rate change, your stroke volume, your cardiac output, your VO2, your rate pressure product, and your mean arterial pressure? We really don't care about systolic. I guess we'll write them. Parasympathetic and sympathetic. Now, how do these all change? Compared to your untrained max, your heart rate is actually the same, because your max heart rate does not change. Remember that. 220 minus your age. It decreases with age. Nothing you can do will increase your max heart rate. Your stroke volume increases because since you're in better shape, or since your max is now much greater, something has to be contributing to your much greater ability to exercise. It's not your heart rate, because that's not changing, so your stroke volume. And thus your cardiac output is different. It's higher because of that formula. Your cardiac output is higher, your VO2 is higher, your rate pressure product is the same because your heart rate is the same. Rate pressure product only depends on heart rate and systolic blood pressure. But since your heart rate is the same, your rate pressure product is the same. Mean arterial pressure is the same. Don't really have a conceptual reason why. This is the same because when you're exercising, your parasympathetic isn't even there. You get your maximal. Sympathetic's not really changing. Okay, since I can't talk, this video is over.